Now, let's take a look at how to identify horizontal asymptotes. So when we speak of horizontal asymptotes explain the end behavior of graphs of rational functions as the x values get smaller and bigger. So as x goes to negative infinity or positive infinity, that's going to help us explain a little bit about the behavior of the graph of rational functions. And then horizontal asymptotes are determined by the degrees of the numerator and the denominator of your rational function. So in order to determine the horizontal asymptotes, again, we're going to have to look at the degree of the numerator and the denominator of the rational function. So we have three different conditions that we're going to apply in order to determine the horizontal asymptote of your rational function. So first we say if the degree in the numerator is greater than the degree in the denominator, then we say we have no horizontal asymptote. All right, instead we have what's called a slant asymptote. Okay, we'll get into exactly what that is. All right, but first, if the numerator is greater than the denominator, no horizontal asymptote. Second condition is if the degree in the numerator is less than the degree in the denominator, then the horizontal asymptote is going to be at y equals 0. Then the third condition, if the numerator is equal to the degree in the denominator, then the horizontal asymptote will be the ratio of the leading coefficients of the degree for the numerator and the denominator. So therefore, we're going to have an equation that looks like y equals some number. So we're going to take a look at exactly what we mean by the ratio of two leading coefficients. So the coefficients in the numerator, the leading coefficient in the numerator, and the leading coefficient in the denominator. So let's take a look at an example of that first condition. So remember the first condition was if the degree of your numerator is greater than the degree of the denominator by 1, then we said we have no horizontal asymptote. So let's take a look at this example. You can see that the degree in our numerator here would be 2. The degree in your denominator, that's an understood 1 for the exponent on the x here, so the degree in the denominator is 1. So the degree in the numerator is 1 more than the degree in the denominator, so therefore we say we have no horizontal asymptote. Remember, horizontal just goes from left to right, so you can see we don't have a dotted line that's going in the horizontal direction, but instead we have a slant asymptote. So you can see this green dotted line here that represents the slant asymptote. So you can see the graph here, this blue line represents the graph of this function, and you can see that it gets very, very close to that dotted line, but it's never going to cross over that asymptote. Now, the way in which we can find this equation for this slant asymptote is to simply apply long division or synthetic division in order to get this equation. All right, so just remember, if the degree in the numerator is larger than the degree in the denominator, then we say we have no horizontal asymptote. Now let's take a look at an example of that second condition. So remember the second condition said if the degree in the numerator is less than the degree in the denominator, then we have a horizontal asymptote at y equals 0. So let's take a look at an example. Look at this function here. We can see that the degree up top is 1. That's an understood 1 for that exponent on this x. And then the degree in the denominator is 2. So we can see that the degree in the numerator is less than the degree in the denominator. So if we take a look at the graph of that function, then we can indeed see that we have this dotted green line going across the x-axis. And so therefore, that is where the horizontal asymptote occurs. So it occurs at y equals 0. You will notice that the graph here on the far right and the far left, you can see that it actually will never cross that horizontal asymptote. But you may notice here in the middle, it looks like a piece of the graph does cross over the horizontal asymptote. So we can make a note that the horizontal asymptote may be crossed by the graph, but we will realize that it's not the case for vertical asymptotes. So you can see we have a vertical asymptote here at -5 and +1. Remember, we get the vertical asymptotes by setting the denominator equal to 0, factoring it and solving for x. If we do that, we'll see we get a vertical asymptote at -5 and +1. And we'll notice that the line will never cross over the vertical asymptotes, but it's possible that it'll cross over our horizontal asymptote. So again, since the degree in the numerator is less than the degree in the denominator, then we say the horizontal asymptote is y equals 0. And then again, we'll note that the graph of rational functions will never cross over the vertical asymptote. So the vertical asymptotes are those lines going up and down. Never cross over those. However, the graph may cross over your horizontal asymptote. The asymptote is that line there that goes from left to right. And finally, let's take a look at an example of that third condition, that last condition. Remember, that condition was just saying if the degree in the numerator is exactly the same as the degree in the denominator, then we're going to have to look at the leading coefficients of what we have in the numerator and the denominator. So here you can see the degree in the numerator is 2, and the degree in the denominator is also 2. So these two have the exact same degree. Okay, so those degrees are equal. So therefore, we're going to have to look at the leading coefficient in our numerator and the denominator. The leading coefficient in our numerator we can see is 3, and then the leading coefficient in the denominator, well, that's the understood 1 there in front of that x squared. So we're going to look at the ratio of 3 over 1. And so therefore, the horizontal asymptote would just be the leading coefficient of the numerator, which is 3, over the leading coefficient of the denominator, which is 1. And so if we can simplify, then we will do that, which just simplifies to 3. So therefore, we have a horizontal asymptote at the equation y equal 3. So you can see here, if we take a look at the graph of that function, you can indeed see this dotted line, this horizontal line going from left to right, and that is where the horizontal line occurs. Horizontal asymptote occurs at y equal 3. Again, you'll see the vertical asymptotes going up and down. That's if we take the denominator, factor it, set it equal to 0, we'll get those vertical asymptotes. But since the degree in the numerator is exactly the same as the degree in the denominator, then we just take a look at the leading coefficients, divide those, and simplify if possible. Again, you'll notice that the blue line represents the graph of that function. You'll see that it does cross over the horizontal asymptote, but it never crosses over the vertical asymptote. So we'll always have to keep that in mind. Now for our second example here, we have 12x cubed over 3x squared plus 1. We can see that the degree in the numerator is 3, and the degree in the denominator is 2. So our degree in the numerator is 1 more than the degree in the denominator. So therefore, we say we have no horizontal asymptote. And the condition that we applied there was that the degree in the numerator was greater than the degree in the denominator. Now for this last example, we have 15x over 5x squared plus 1. The degree in the numerator is understood to be 1, and we can see the degree in the denominator is 2. So we can see that the degree in the numerator is less than the degree in the denominator. So therefore, the horizontal asymptote for this case would be y equals 0. And the condition that we applied to this one is that the degree in the numerator is less than the degree in the denominator. So therefore, we say the horizontal asymptote is y equals 0.